Hey everyone, hope you are doing well today. In this video, I'm just going to be making an answer key for the Unit 5 Homework 2 on ratios and rates and some applications of them with some not just part to part, but also part to whole types of ratios. Let's get right into it. For number 1, we see that Josie reads 14 pages for every 9 pages that Lizzie reads. So Josie is going to be associated with the 14, and then Lizzie is going to be associated with the 9. Those are the numbers that go with each person. And for Josie, I'm going to use a J to just kind of use that as shorthand, and for Lizzie, I'm going to use just an L. For part A, writing the ratio 3 different ways, I'm going to start off by just writing 14 to 9 using the word to. And then I'm going to go ahead with using maybe the colon, and I'll say 14 first, and use the 2 dots, which is the colons. Whoopsies, 14, right like that. And the 9 is going to be put in that color. And the last one, this one's the one that looks like a fraction, but it really isn't a fraction. It's just the fraction form of the ratio. Okay, so those are our 3 different forms. So that's part A. For part B, Lizzie reads 27 pages. Then how many pages does Josie read? So if we are going to write for part B, we see that if Lizzie reads 27 pages, how many pages does Josie read? So I'll start off by just kind of labeling a ratio. So we'll have Josie, and we know that she reads 14 pages. And we also know that Lizzie is going to be reading 9. So I'm just going to set up a fraction form ratio. That's usually the easier one to use for equivalent ratios. And we need to figure out what the equivalency here is. And if Lizzie read 27, that's going to go on bottom. So we have to figure out 9 times what equals that 27. It's going to be times 3. And 14 times 3 is going to be 42. So the question says, how many pages does Josie read? And you would say 42 pages. That's part B. For part C, we see if Josie reads 7 pages, how many pages did Lizzie read? And I'm actually just going to go ahead and copy this just to save a little bit of time here. And so this is the original ratio, and if Josie read 7 pages, that's going to go on top because everything that Josie's reading is on top. And to get from 14 to 7, we'll divide by 2. So we have to divide 9 by 2. So if Josie were to read 7 pages, we'd expect Lizzie to read 4.5 pages. A better answer right over here, 4.5 or 4.5, either one's fine. Now part C is done. And finally, if Josie and Lizzie read 46 pages in total, the question is how much did each of them? And for part D, it says if Josie and Lizzie read 46 pages in total, the question is how much did each of them read individually? So once again, I'm just going to copy and paste this bit. And so we have this kind of set up. Maybe I'm running out of room there. I think I can squeeze it in. So we have that as Josie and what Lizzie did. And now the question is talking about what they read in total. So we actually don't have that there yet. So if we just kind of add and see what's the total, I'll write that word total. And the total, if Josie read 14 and Lizzie read 9, keep in mind that you can add those two numbers together, and that'll be 23. And they're saying, well, what if they read 46 pages in total? Well, how do we get from the total of 23 to the total of 26? We got to multiply it by 2. And if we multiply that by 2, we'll also multiply these values by 2. 14 times 2. So if they read double the pages total, Josie must read double the pages, and Lizzie must also read double the pages. And just keep in mind, if you want to check if this is correct, you can add 28 and 18, and it does equal 46. So this is good to go. We can just put a check mark and say, yep, this one is also good. So it says, how much did each of them read? I guess individually, we can say that, I'm just going to kind of abbreviate here. Josie did end up reading 28 pages, and Lizzie ended up reading 18 pages. That will be the answer for this. It's asking for them individually, and they gave us the whole. We just had to do a little bit of work to get there. All right, all of number 1 is now done. Let's take a look at number 2. Okay, so the ratio of students to teachers at Chipotle Middle School is 2 teachers for every 26 students. So in this case, for teachers, I'm going to put a T, and for students, I will put an S just to kind of shorthand that. And let's take a look at part A. If there are 8 teachers, how many students should there be? We can start off by writing a ratio. I'll use T to say this is going to be 2 teachers. And for students, I can put an S here. It's going to be 26 students for every 2 teachers. It's a pretty small class size. And the question says, well, what if there's 8 teachers? So if there's 8 teachers, that'll go on top with the teachers. And how do we get from 2 teachers to 8 teachers? That's times 4. So on the bottom, we're also going to multiply by 4. Now for 26 times 4, I'll do that in my head, but I can also just write it out just in case it's helpful for anybody to see. That's going to be 24. That's going to be, and then 104. So if there were 8 teachers, we can say that we know that there are 104 students. That'll be our answer, 104 students. Cool, that is good to go. All right, part A is now done. If there are 13 students in part B, how many teachers would there be? So I'll just go ahead and copy this and paste that right over here. And if there are going to be 13 students, well, students goes on bottom, put that right here. 26 divided by 2 will get us that 13. So 2 divided by 2, that's going to be 1. If there's 13 students, there should be 1 teacher. 1 teacher, that's our answer. Perfect. Done. And now part B is done. Let's take a look at part C. If there are a total of 252 students all together, keyword total, actually, I'll use that color I'm going to use for the total. Actually, I'm going to use that color for total. The total is going to be 252 students and teachers. Okay, that's them together, students and teachers. So how many are there individually? I can go ahead and paste this I can go ahead and paste what we wrote earlier. And so we already have the individual ones, but we need to get the total because they tell us a total of 252. So I'm going to try to keep my colors organized here. 252, well, the total here is 28. 2 plus 26 is 28. That's not the 252. So we have to figure out what if there were 252 students. 28 times something is 252. To find out what that something is, really you should do 252 divided by 28. Okay, 28 is not going to go into 2. It's not going to go into 25. So it goes into 252. It turns out it's going to be 9. 9 times 28 does exactly get you 252. So 28 times 9 gets you there. Then we have 26 times 9 and 2 times 9. So 2 times 9, there'll be, if we have 9 times more teachers, that's 18 teachers. And if we have 9 times more of the students, 26 times 9 is going to be 234, I think. 234. I'm pretty sure that's right. Yeah, okay. And one more time, we can also check this 18 plus 234. This is probably an easy way to check, actually. If you add these two together, it's going to be ending in a 2, carry the 10, 40, 50, 250. Yeah, this works just fine. So the question says, what if there were 252 total people? That's this 252 at the bottom. Then how many are there each? Well, those are these two numbers here, right? So we can say there would be 18 teachers and 234 students. Okay, cool. So these would be the total amount that adds up to 252. And that is part C. So question 2 is now complete. Okay, let's take a look at number 3. Mr. Lee is really picky and only eats red and blue M&Ms. I guess it's only fitting if I use some sort of reddish color for this one and some bluish color for this one. So red, there's going to be 18 red M&Ms for every 4 blue M&Ms. Okay. The question says if there are only red and blue M&Ms and we have, Mr. Lee has 300, this is 300 total M&Ms. How many are blue and how many are red? So the question is, how many individual ones are there of each of these colors? Okay, so let's set up some sort of ratio to begin for part A. So let's see, I'll go with blue, I'll go red first, put red on top. We know that there are supposed to be 18 red ones for every 4 blue ones. So there's a lot more red than blue. Okay, that's our initial ratio, and we have to see what this is equal to. We don't know what's going to be over there, but they do tell us a total. So I'll go ahead and draw a line here. just like we've done in the past couple problems, the total 18 plus 4 is 22. So we have to find out how 22 becomes 330. 330. So let's see, 22 times, well, I can write it out. I think it's 15, but maybe it's helpful. I'm going to try to write out as many steps as I can to be very thorough here. 22 goes into not 3, but 33 once. That's 22. We subtract, that is 11. Bring that down, it's 10. 5 times 22 is 110. Yeah, I was right, 15, exactly. So it's going to be 22 times 15. And whenever you don't know that number, just go ahead and just divide. That'll get you that number. 18 times 15, pretty sure that's 270, if I'm not mistaken. Actually, yeah, it has to be, because 15 times 4 on bottom is 60. And if you just subtract 330 minus 60, does equal 270, since 270 plus 60 equals 330. Okay, so the question said how many blue ones and how many red ones. Well, for blue, well, it doesn't matter, but I can say for blue, that is going to be 60. And then for red, we can say that's 270. That would be the answer for this first part if there were 330 and we kept the same ratio of 18 to 4. That's part A, all done. And let's take a look at part B. If Mr. Lee has a 1 blue M&M, that's right here, 1 blue M&M, then the question is how many red ones are there going to be? All right, well, let me just steal this, copy and paste it. This is my work for part B. I'll draw an arrow just pointing down. This is part B. And we are saying there's 1 blue M&M that's going to go on bottom, and 4 divided by some number. 4 divided by 4 equals 1. And 18 divided by 4. That is just 4.5, but maybe it's good if I show this. 4 times 4 is 16. Subtract, that's going to be 2. It says 4 and 2/4 is 4.5, but maybe some of you prefer decimals. I don't know. If I put a decimal 0, that's 5 times 4 is 20, and we get 4.5, which is the same thing as 4.5. So 4.5. So if there was 1 blue M&M, then there would be 4.5 red M&Ms, or 4.5 red M&Ms. That'll be the answer for part B. And done. Okay. Now let's take a look at part C. What if Mr. Lee has 54 red M&Ms? The question is how many total M&Ms? Oh, I should use purple to represent the total. We're not looking for blue, we're looking for all together. So for part C, I'll go ahead and draw an arrow for part C. Whoops. Go ahead for part C. I'll draw an arrow right over here roughly. And it does talk about the total, so I'll put that at the bottom here. It's not really part of the ratio, but just try to separate it. The total here is 22, right? And it says, what if Mr. Lee has 54 red ones? How many total does he have, right? So the 54 is going to be going on top, and we don't really know anything else. So we have to figure out how does this 18 times what number gets you 54? Well, 18 times 1 is 18. 18 times 2 is 36. Oh, and 18 times 3 is 54. Okay, so that does work out nicely. This is times 3. You can go ahead and multiply it out if you want to just double check and multiply by 3 for all of these. We don't need to write this here, but we can write the 12 just in case. But we can also just multiply 22 times 6, and that will be a total of 66 total M&Ms. And if you wanted to add them, you're totally welcome to add these two up. You do get 66 that way. But once we found out this 3 was the important number to get from the 18 to the 54, then that 3 was also going to help us get the 66 that we were looking for. So for the total M&Ms, we will say there are 66 in total. That would be the answer for part C. That one's done, and that means all of question 3 is finished. Okay, and let's slide on down. Let's take a look at number 4. For the puppies, I will use green. 8 puppies for every, for every 6 kitties in Mr. Lee's classroom. I like puppies more, so I put more of them. Allergic to kitties, actually. If there are 108 kitties, that will be this color right over here, then how many total animals are there? So total, again, I'm going to keep using purple for the total to keep it consistent. So let's see. I will do P for puppies, and there are 8 of them. And we can use this K for kitties. K will be 6, and we can set up that initial ratio. And it says, what if there are 108 kitties? Well, that's not going to go on top. That'll go on bottom with the kitties. And we have to figure out how many total animals there are. So we're going to need that purple part for the total. Okay, so the total here, 8 plus 6, that is 14. So let's just write down any information we can get. And now let's figure out how we get from 6 to 108. I think that's going to be, I'll just write it out. 108 divided by 6, that's 1. That's going to be 6, 4, 18, I think. Yeah, 18. That's going to be 48, and that'll be 0. So it's going to be multiplied by 18. So we know 6 times 18 gets you 108. And I guess I could do it on top, but it's not necessary. We could just do it on bottom here. 14 times 18 is what we really need to do. So I'll just multiply out the top just in case. 18 times 8, that's going to be what, 64? Carry the 6, that's going to be 144. So not necessary, but you can put it up here and then I guess just add. 144 plus 108 is 252. That should be right. 252. That would be the total. And maybe just to check it and show you if you prefer to do it the other way. Again, I'll try to make this key as thorough as possible for anybody learning it in a different way. 8 times 4 is 32. Carry the 3. That's 11. That's a 4. That's a 1. 2, 5, and 2. So this does work out. So the question said was how many total animals? We can go ahead and say there would be 252 in total. Okie dokie. If there are 4 puppies, then how many total animals would there be? So I can go ahead and steal this, save myself a little bit of writing, and take a look at part B. Oh, part A is done, by the way. Part B, what if there's 4 puppies? Well, puppies are on top, and put that on top. 8 must get smaller to get 4, divide by 2, divide by 2. 6 divided by 2 is equal to 3. So the question says, how many total animals would there be? And if we did the total, okay, I'm not going to write the word total. I hope that's clear at this point. That's going to be 7. So there would be 7 total animals. 7 in total. Okay, half the amount of puppies, half the amount of kitties, half the amount of total animals. Part B is now complete. Let's take a look at part C. What if there are 84 animals in total? How many puppies? How many puppies? And how many kitties are there? So we have to answer 2 questions. How many puppies, how many kitties if there's 84 in total? Well, go ahead and take our original ratio. I guess I could have copy and pasted that part too. That's okay. So 8 plus 4, or 8 plus 6 rather, excuse me, is going to be 14. It says, what if there are 84 in total? Well, 84 is going to go over here in the total area. So 14 times some number must get us 84. I hope it's not a fraction or a decimal. Maybe I'll erase some of this other scratch work for now since this is a video and you can go back and look at it. 14 times, I guess you could use long division, but I think we're going to have to multiply anyway. 4 times what ends in a 4? Well, 4 times 6 is 24. That's going to be my best guess here. And this is 84. Awesome. So it's going to be 6, and this will be times 6, and this will be times 6. 8 times 6, 48. So 48 and 6 times 6 is going to be 36. And again, if you want to check this, you can add this and this together. 30 plus 40 is 70. 8 plus 6 is 14. 70 plus 14 is 84. So this does work out. How many puppies, how many kitties? We would say for the puppers, for the puppers, the dogs, we got 48. And for the kitties, we'll say the kitties is going to be 36. Okay. And I'm kind of abbreviating here. Hopefully that's still clear to you what I am doing. That is part C, as well as number 4 is now complete. Okay, let's take a look at number 5. We have 2 types of fans here. We have Chipotle fans, 35 Chipotle fans for every 5 Qdoba fans. That sounds about right. Chipotle's better. So it says, how many Chipotle fans are there if there is one Qdoba fan? So one Qdoba fan. Okay, let's set up a ratio. I'll use C for Chipotle, and I will use a Q for Qdoba. So we can write, I'll go ahead and write a ratio here for Chipotle. That is going to be 35. And for Qdoba, that is going to be a Q, and that's going to be 5. Okay, that's our ratio. 35 to 5. They're outnumbered. And they're saying, what if there's only one Qdoba fan? Poor Qdoba fan. To get from 5 to 1, that's divided by 5. To get from 35 to that blank up there, that is just going to be 7. So if there was only one Qdoba fan, we would say there'd be 7. Sorry about that. 7 Chipotle fans. Chipotle. 7 Chipotle fans. Okay, part A is now done. It says how many Qdoba fans are there? How many Qdoba fans are there if there are 175 Chipotle fans? Okay, well, let's go ahead and steal this so I don't have to rewrite everything right now. We have this, and it says, what if there's 175 Chipotle fans? Well, that's on top for Chipotle. That's right here. And we have to figure out, okay, 35 times what number gets you 175? I guess I'm getting a little lazy here, but if we do the long division, I believe it should be 5. And this is times 5. And 5 times 5 is going to be 25. It's not that I'm using a calculator, I'm just doing it in my head. But hopefully that makes sense. 175, 25. And if you know how to multiply and divide, obviously, if you use a calculator, it's not a huge deal. But if you struggle with it, that's something it's good to practice. So if there were 175 Chipotle fans, there would be 25 of these Qdoba fans. So, spell that right, Qdoba fans. Still outnumbered 7 to 1, right? For every one Qdoba fan, there's 7 Chipotle fans. So that should be a lot less. Part B now is complete. What about part C? How many fans of each are there? Of each, okay, if there are 360 altogether. Okay, if it says altogether, just take note that is dealing with a total. So we'll go with this. I will draw that line to show the total. The total here is what, 40? 35 plus 5 is 40, and we're trying to get to 360. Oh, thank goodness, this is not too bad. 4 times 9 is 36, so 40 times 9 is 360. Multiply these by 9 as well. 5 times 9 is going to be 45. Put a 45 down here. I don't know what 35 times 9 is. I guess you'll do, but you could just do 360 minus 45. That'll be 315. 315. And you could check this. I'll try not to be lazy. I'll write it out. 35 times 9 is going to be 45. Carry the 4, 315. Okay, cool. So it says how many of each would there be? We could say that there would be, I'll abbreviate here, hope that's okay. Chipotle would be 315, and then Qdoba would be 45. And that's if there were 360 total people, and that should add up to 360, which it does. Part C, complete. What if there are 440 total fans? How many of them are Chipotle fans? Okay, that's nice. We don't have to find the Qdoba if we don't want to. We just have to find Chipotle fans. And so we have, where should I put this? I'll put this right here. And I'll put my total here, 440. Well, we know this is 40. So this is 440. 4 times what is 44 if you ignore those zeros? Thinking 11? Times 11 times 11 times 11. This is 55, but we didn't need to know that. And, oh, did I just change colors? Oopsies, they're kind of close. And a 35 times 11, 35 times 10 is 350. And we have an extra 35. So 350 plus another 35 is 385. So 385. Okay, if there were 440 total fans, 55 then would be Qdoba, but 385 would be Chipotle fans. Oh gosh, I'm getting lazier and lazier, but I've abbreviated as a C for Chipotle. All right, cool. That's the first 5 problems done. Let's take a look at number 6. Okay, the ratio of Oh gosh, there are 3 things here, everybody. There's Reese's, 8, and then there are Snickers, which is 3, and then I'll use a different color here. I use gray. Twix. Twix is going to be 6. Okay, so yeah, it's gonna be a little bit weird, I guess, because there's 3 things, but don't worry too much. We can handle that. For part A, let's abbreviate. Let's make this R. For Snickers, I'll put an S, and for Twix, I will put a T. Okay, so I'll set up a ratio down here for part A. I don't know why I chose it to do this way. I've been squeezing everything in. Hopefully it's not too messy for everybody. You can still follow along. That's the Reese's. For the Snickers, Snickers is going to be 3. Put that right over there. And you can, if you want, you can comment and let me know if you have a favorite of these 3. I like all of them actually, just different ways. But Twix is probably the one I could probably eat the most of. I like Reese's, but I can't eat a lot of them. Okay, so we have this. I know it's kind of weird. I put a fraction on a fraction. It's kind of strange, but for our purposes, it's not really a big deal. It says, what if there's 18 Twix? I don't really know where to put the equal sign here. It's kind of awkward. I'll just put the equal sign in the middle. If there are 18 Twix, I guess I'll put this here and here. 18 Twix would go down here. The question says, how many Reese's are there? Okay, well, 6 times 3 is 18, right? So we would have to multiply each of these by 3. The question asks about Reese's, so Reese's would be 24. If you needed Snickers, that would be 9, but we don't really care. We care about, what do we care about? We care about this one right here. It's 24, right? So how many Reese's would there be? You could say there would be 24 Reese's. Is that how you spell Reese's? I don't know. Sorry if I spelled it wrong. Besides the point, they're still yummy. Okay. What about if there are? This is gonna bother if I don't do it because I did it on all the other problems. Reese's was gonna be this one, so we were looking for that. So if there's 27 Snickers, how many Twix would there be? So we're looking for the gray. All right, not too bad. Let's steal this. Does that seem right? So we finished part A. I don't need this circle, but I can label this as part A. I'm doing part B right now. And it says, what if there's 27 Snickers? Well, that goes in the middle. That's nice. And okay, so how does 3 become 27? I think it's times 9, right? So this will be also times 9. This will also be times 9. This will be 72 on the top, but that was not what we're looking for. 6 times 9 is 54 on bottom. This is what we were looking for. So 54. This should be 54 Twix. And done. Okay. That was part B. And moving on to part C. It says, what if there are 64 Reese's? Reese's is this green one here. How many Snickers and how many Twix? Okay, they're asking a lot here. I guess I'm asking a lot. I made this. There's 2 of these. 64 Snickers. Okay, part C. 64. I guess what can I do here? How do I write the least amount? Copy this while still giving you all the details. 64 Reese's, 64 goes on top. Snickers and Twix, they're asking for both. Okay, 8 times 8 is 64. Multiply these. 3 times 8 is 24, and 6 times 8 would be 48. That is great. So how many are there of each? For Snickers, sorry, I'm abbreviating, that's going to be 24. And for Twix, Twix would be 48. Okay, part C is done. Part D, what if there's 51 total pieces of candy? All right, well, let's go ahead and try part D here. Part D, what if there's 51 total? So I'll go ahead and make a new row at the bottom. Maybe I can make that a little straighter. Okay, cool. And I'll put 54. I think that's what they said. No, 51. 51 is the total. That is not the total over there, though. 51 is the unknown. The total of the unknown. What's the total of what we do know? 8 plus 3 is, here, 8 plus 3 is 11. 11 plus 6 is 17. Okay. The total that we do have is 17. So 17 times what is 51? Times 2 is 34. Times 3, that's another 17. That's 51. Okay. It's times 3. And so this is times 3, and this is times 3, and this is times 3. 8 times 3, 24 Reese's, and there would be 9 Snickers and 18 Twix. If you want to, add these up. This plus this is 27. 27 plus 24 is 51. So we are good to go. So it says how many Reese's, how many Snickers, and how many Twix. They seem to ask for Reese's, they ask us for the Snickers, and they ask us for the Twix. So for Reese's, we can say, I guess I'll keep using black here. For the Reese's, we have 24. For the Snickers, we have 9. And for the Twix, we have 18. Okie dokie. That is good. There's our answer. Okay. Part D is now done, and finally we are on part E. It says if there are 12 Snickers, how many total pieces of candy are there? One more time, we can take this, and it says what if there are 12 Snickers? And we also need a total. I think it does ask us the total. Why am I not drawing anything straight? Okay, so 12 Snickers, what is that? This color here? It says how many total. They're asking for the total here. So the total in the last one we actually figured out was 17. So they're saying what if there are 12 Snickers? 12 Snickers goes here. 3 times 4 is 12. So this times 4 and this times 4 and this times 4. You actually don't really need to fill in these pieces here because you could just do 17 times 4. But I'll just write it in. 8 times 4 is 32. 6 times 4 is 24, and you could add up these 3 numbers, or you could do 17 times 4, and I already know that's going to be 68. Just use my big brain, and yeah, that's the total pieces of candy. So we will write 68 in total. Cool, and that is the last part of 6, and all of question 6 is now complete. All right, so part 2, we're going to be taking a look at some tables and filling in the correct numbers so that these tables all make sense and represent ratios. We can check the solutions if we would like to by multiplying the diagonals or multiplying or dividing top and bottom. I can go over that in just a little bit as well. Okay, so just something to take note in the directions that we're looking for the unit rate. So for this one empty column, we're going to put in that 1 right here. The unit rate is per 1. So that's going to help us figure out some other things as well. So how does this 4 become 1? Well, that's going to be divided by 4. And so this is also divided by 4. 32 divided by 4 is equal to 8. And that is what is going to go right there. All right. Now, the reason why we want to do the unit rate first is just because 4 to 5 doesn't go in nicely. It's multiplied by 4.25, but that's not as nice for most people to do mentally. So the reason why we find this unit rate of 1 here is 1 nicely goes into 5, right? So we can see that 1 multiplied by 5 will get you 5. So then 8 times this 5 is going to get us the 40, and that fills in this box right here, okay? At this point, we can't really get to this 12 very easily. 40 doesn't get to 12 nicely. 8 isn't terrible. 32 is also pretty bad. So maybe I'll pause and skip that one for a moment. To get to this 10 though, this isn't too bad. We could just double the 5. We could also multiply this one by 10. 4 is not nice at all, but I think I'm just going to double the 5. That's not bad at all. So 5 multiplied by 2 gets you 10. And then 40 multiplied by 2 is going to get us 80. And that goes right over here. Okay. At this point, we kind of did all the nicer ones, and we just have to figure out what's going to go beneath this 12. And so I think the nicest number here is going to be this 8 here, actually. 8 times something gets you 12. And if you're wondering what that is, well, 8 times something equals 12. That means 12 divided by 8 will get you that something. 12 divided by 8 is 12 over 8. That is 1 4/8, or 1 1/2. So if we multiply by 1 1/2, turns out 8 times 1 1/2 does get you 12. So we can say 1 times 1 1/2 will get us this number, and that just has to be 1.5. Okay. Now, how can you check this easily? You could take this 4 and 8, that's multiplied together, it's 32. 32 times 1 is 32. 1 times 40 is 40. 8 times 5 is 40. 5 times 12, that's 60. 40 times 1.5 is also 60. 12 times 10 is 120. 1.5 times 80 is also 120. That's one way to check it. And just so you're aware, you can also divide these to check it. 32 divided by 4 is just going to equal 8. 8 divided by 1 is 8. 40 divided by 5 is 8. 12 divided by 1.5 is 8. And 80 divided by 10 is also 8. That's kind of where the whole unit rate comes from. That's useful. Okay. Move on to number 8 now that 7 is complete. Let's take a look at these ducks and chickens. So again, we're going to start off with finding the unit rate, which is going to be per 1. So how does 4 become 1? Well, it's just going to be divided by 4. So that means to get from 5 to this blank, it's going to be 5 divided by 4. Now, if you're not sure what that is, no worries. 5 divided by 4 is just 1 1/4. Okay, so 5 divided by 4, we can just write that as a fraction or a decimal. If you want to say 1.25, that's also okay. And now that we have this unit rate, this should make our lives a little bit easier. Again, this is the unit rates per 1 chicken or per 1 of something. And we can actually get to each number, because to get from 1 to 5, that's pretty straightforward, right? 1 is a nice easy number. It's times 5. Actually, I'll put it right over here instead. Times 5. And this is also times 5. 1 1/4 times 5. Well, we know 1 1/4 is still this 5 quarters. So we'll take the 5 quarters and multiply that by 5, which is 5 over 1. That's going to be 25 quarters. And 4 goes into that 6 times with 1 left over. So that's going to be 6 1/4. Now going from 5 to 8 is not very nice, but going from 1 to 8 is not bad. But we still have a fraction here, and I don't really want to have to multiply this by 8. So maybe going from 4 to 8, oh, that's not bad at all. That's just a double. So 4 times 2, right? So we can go from 4 to 8 multiplied by 2. That means 5 times 2 is going to get us equal to 10. And I think that's actually, that's pretty nice there. Okay. And then for this last one, we have, and so for this last one, from 4 to 12, that we can just multiply by 3. And then from 5 to this blank, we can also multiply by 3. So that means that we need to put a 15 right above this 12. Okay. If you want to check this, obviously you're welcome to. 5 times 4, 5 times 1 is 5. 4 times 1 1/4. So 5 times 1 here is going to be, all right, so to check this, we can say 5 times 1 is 5. 4 times 1 1/4 is also 5. 1 times 6 1/4 is 6 1/4. 5 times 1 1/4 is also 6 1/4. This is 50. 5 times 10, this is also 50. This is 120, and this is also 120. Okay, easy way to check. You could also, as like I showed you in the last one, you could divide these. 5 divided by 4 is 1 1/4. Divide this, that's 1 1/4, 1 1/4, 1 1/4, 1 1/4. If you divide the top by the bottom, you'll get the unit rate number, right? So per 1, that's what the number is you're going to get. Okay, for this next one, we have flour to sugar. Let's do it per 1 unit of sugar, whatever that's measured in. And to get there, we are going to go ahead and divide this one. We'll divide by 4. 4 divided by 4 is 1. And what do we have? 3 divided by 4. That's just going to be 3/4, right? Don't overthink division. You can just use fractions like that, 3/4. Okay. Now, you have a couple options. You can double the 1 to become 2, and then you can double this, right? That's doable. I think it's actually a little bit easier to take half of 4 and then take half of 3. So that's what I am going to do. Go from here to here. Let's divide that by 2. So from here to here, dividing that by 2, we will get 1 1/2. Okay. Again, if you found it easier to double the 3/4, that's also perfectly fine. Just a preference thing. You have a few options here as well, but I think I'm just going to double the 3 to get the 6. That's not bad. just times 2. Double this 4 times 2. That's going to give us 8. Okay. And for this last one, let's see. I think I'm just going to go from this 1. 1 times 9 just gets you 9. I like that unit rate because 1 goes into everything. So we have to multiply 3/4 by 9. So let's see here. 3/4 multiplied by 9. Unfortunately, we can't cross cancel, but that's okay. We'll get 27 over 4. 4 goes into that 6 times. Yeah, 6, that's 24. And 3/4 left over. So we have 6 and 3/4. Okay, you can check this, multiply these, this will be 3. Multiply here, the 4s will cross cancel, that's 3. Multiply these two together, it's going to be 1.5. 2 times 3/4 is 1.5. 2 times 6 is 12. 8 times 1.5 is 12. 6 times 9 is 54. You can check 8 times 6 3/4, that's also 54. Okay, so we finished 8, we finished 9. Just a couple more to go. Let's take a look at these chocolate chips and cookies. So we know how many chocolate chips there are for 2 cookies. Let's figure out what it is for 1 cookie, since this column right here, like in the last one, is their unit rate. So how do we get from 2 cookies to 1 cookie? Well, that's just half. That's half as many divided by 2. 15 divided by 2, that will be 7.5 or 7.5. I don't know, I feel like doing decimals now. Let's do decimals. Okay. And for this next part, let's just go ahead. How does 1 become 3? Just multiply by 3. 7.5 times 3. That's not bad. I can just take that on the side. 7.5 multiplied by 3. That's going to be 15. Carry the 1. All right, 22.5 is how many chocolate chips you would have for 3 cookies. Now for this next one, I think I'm going to go from 15 to 5. I think that makes the most sense for me. Divide that by 3. So then 2 divided by 3. Well, I feel like using a fraction now. I guess we could say a decimal is 0.6 repeater. But sometimes people are uncomfortable with repeaters. But it's 2/3, right? 2 divided by 3 is just 2/3. And finally, for this last one, I think 3 makes the most sense. 3 times 3 is equal to 9. So we have to do 22.5 times 3. I can do that up here. 22.5 times 3. It's going to be 15. Carry the 1. 6, that's 7. And I think that's a 6, so 67.5. 67.5. I believe that's correct. This is 15 and 15 if you multiply. This is 22.5, 22.5 if you multiply. This is 15. 2/3 times that is, yeah, I think that cross cancels nicely. 2/3 of 22.5 is 15. Yeah, that makes sense to me. And this is 45, and then 2/3 of that. Yep, that is 45 as well. Cool. Wonderful. Number 10 is now done, and now that leaves just number 11 left. So we want to find the unit rate first, which is per 1. And so we can go ahead and do that. How do we get from 9 to 1? That's just going to divide by 9. So over here, we're going to do 6 divided by 9. 6 divided by 9, don't overthink it. That's just 6 over 9. And you can simplify that down to 2/3. Okay, 2/3 is how many completed passes for 1 interception. Not very good here. Now that we have a unit rate, we can actually pretty easily go from 1 to 4. It's just times 4. And so 2/3 times 4 will be how we get to this blank here. So we can go ahead and take this 2/3 and multiply by 4. Can't cross cancel, unfortunately. That's 8/3. That's going to be 2 and 2/3. 2 and 2/3. That's the number of completed passes for the interceptions. And now to get to 12, I want to use the 6. I think that's not bad. So times 2. 9 times 2. So some of these are easier than others. This is going to be 18. And then for this last part, we have the 4 at the end. Oh, this is kind of silly. I forgot about this. These are the same numbers, so this number should match this number. That was just an accident, but you're welcome for the freebie. That's 2 and 2/3. Okay, that is number 11. Okay, so if anybody's interested in doing some of these enrichment problems, I can go through and try solving just a few of these. I don't think I'm gonna go through all 24 of them, but I can go through just a few. Instead of leaving blanks, we actually just use like variables to represent like what goes here. So each of these are kind of just like a table, and then these are like the blanks in the tables, and then X is in a different location each time, just like they were in the table, all right? So I think the directions for number 1 through 9 are just going to be using equivalent ratios. I think I forgot to put that in there, but 13 times what equals 169? Well, 13 times 13 is 169. So 10 times 13 would get you what the value of X is, and so that X would equal 130. Okay, that's how you would do number 1 here. I can do a few more, absolutely. 15 times, I think it's 12. So X times 12 is equal to 96. That means that X times 12 is 96, so we can say 12X equals 96. Divide both sides by 12 using the division property equality. X would then equal 8. Okay, that would be number 2. For number 3, 25 times something. Well, I know 25 times 3 is 75, so 25 times 30 would be 750. So X times 30 would be 330. We could say 30X equals 330. Okay, and if we divide both sides by 30, division property of equality again, we could say X is equal to 11. That is the number on top that would make the ratio on the left equal the ratio on the right. Okay, so that's just 3 examples over here with 1, 2, and 3. No decimals, so maybe I can try a couple decimal problems. Looking at number 7, turns out 6.2 times 3 is exactly 18.6. So 4.1 times 3 would equal X, and you can do that if you'd like on your own. I think mentally that is just 12.3. Should be correct. Okay. If I go ahead and try, I don't know, maybe just one more with decimals, I think we can do number 6 maybe just to try. We have 2.5. 2.5 times 8 is 20. I know 5 times 4 is 20, and 2.5 is half of 5, so if I took half of 5, I got to double 4 to get 8. So X times 8 is 24. 8X equals 24. Divide by 8, divide by 8. Again, I'm skipping some work here, but I'm just kind of showing you how the thought process would go. X would equal 3. Okay. So I did a few problems from that first part. The next part says use algebra to solve the proportion. And when the directions say use algebra, it just basically is saying to use properties of equality. So for something like number, I don't know, I'll choose a few to do actually. I'll do number 10. If you were to do this, I'll write it on the side. We have 8.6 over 16 is equal to X over 72. And so by using algebra, you would have to isolate X or solve for X. So you'd multiply by 72 over 1 on the left and 72 over 1 on the right. That's the multiplication property of equality. And these 72s would cross cancel on the right side. And X would equal, well, you have to do some cross canceling over here as well. 16 and 72, you can divide them both by 8. So you get 9 over 2. And you can cross cancel these decimals. It just doesn't come out nicely, but this is a 1 if you divide that by 2. If you divide this by 2, you get 4.3. So going ahead and multiplying this 9 and 4.3, I'll just write it out here, 38.7 maybe. 38.7. So X would equal 38.7. That would be this problem. So I'll write that right next to it. X equals 38.7. That seem right? Let's see. Should be a little more than half. I think I did that correctly. Yeah, that seems good to me. If you have to do another one, I don't know, maybe I'll try one like 17, something that looks a little different to me, just a little bit. We can say we have X over 0.75 is equal to 6.4 over 12. Okay, so to use algebra means we use a property of equality, so we'll multiply both sides by 0.75, whoopsies, over 1, and by 0.75 over 1 on the other side as well. These 0.75s are going to cross cancel, and you'll have X is equal to, and we have to figure out the product on the right side. We can divide this by 3 and 3. We'll get 4 and 25. And since I know 4 times 16 is 6.4, I can cross cancel a little bit here and say this will be 1 and this will be 1.6, right? If 4 times 16 is 64, then 4 times 1.6 is equal to 64. So we just have to go ahead and multiply 1.6 times 25, and we can do, all right, 1.6 times 25 up here. That's a 0, that's a 3, that's a 5 plus 3 is 8, that's a 12 with a 1, 2, 3. I think I kept track of everything. Is this 400? With 1 decimal, so don't forget that. That's going to be 40. Okay, so and right here, x, does that seem right? Or does that seem a little too big? 25 times 1.6, that seems right, 0.75. 6.4. Oh wait, this was a 0.25, which means that's a 0.25, so this decimal is actually 0.4, I think. Yeah, I think it is 0.4. 0.40. X equals 0.4. This seems like a good one to check. I think I might have messed something up. I don't know. I think I might have went a little too quickly earlier. So I can multiply the diagonals just to check. So if I take 12 times 0.4, well, that's going to be an 8, and that's a 4, so that's 4.8. And if we take the 0.75 and multiply that by 6.4, that's going to be 0 and a 2. 28 plus 2 is 30. That's a 0, that's a 3, that's 42, 45. 4800 with 3 decimals, 4.8. Oh, okay. I think this is good now. It is 0.4. Okay. So this is us using algebra, and when you use algebra, you use the multiplication property of equality right now, and that will help you find each of these solutions. Okay. And maybe I'll try one word problem to make sure you kind of make sense of this. I'll just pick the middle one here of 23. And I'll do that work down here, lots more space. A painter is making a specific shade of orange that requires 4 parts of yellow paint for every 5 parts of red paint. To make the mixture, the painter uses 12 ounces of yellow paint and 12 tubes of red paint. Interesting. How many ounces are in each tube of red paint? Okay, so yellow, 4 parts of yellow. 4 parts of yellow for every 5 parts red. Red is going to be a 5, so we have a 4 to 5 ratio, and that's just parts, okay? And it looks like to make the mixture, the painter has to use 12 ounces of yellow paint and 12 tubes of red paint. So we need to kind of just label a few things here. So the parts, this is talking about parts, right? 4 parts for every 5 parts. And then we also have to take a look at the actual ounces. So ounces we'll put over here, and then maybe we'll put tubes over here. I don't know. Let's just kind of organize and see what's going to happen here. I'm not too sure yet, actually. 12 ounces of yellow paint. So if we have 12 ounces of yellow paint, well, it's supposed to equal 12 tubes of red paint, but we don't know what that is. Well, for the tubes, I guess I'll put 12 over here for 12 tubes of red. But if we now know this number, how do we get from 4 to 12? Well, from going for ounces, we'll multiply by 3. And from 5, we'll multiply by 3. That should be 15 ounces, right? So we now know that if we have 4 parts of yellow for every 5 parts of red, then in ounces at least, this would be 12 ounces of yellow for every 15 ounces of red. That has to be the same ratio. Now for this to be true, and the question does ask us how many ounces are in each tube of red paint, we need to see, okay, well, if we have 12 tubes and 15 ounces are in each one, then they just say, well, what about one of them? So we can actually write this as a rate and then kind of just simplify it down. So we have 12 tubes. I'll write that here. The tubes, it's 12 tubes. And we know that they're going to be, the abbreviation for ounces is OZ. There's going to be 15 ounces. So the question is, well, what if there's only one tube? So we can divide this by 12 to get the 1, and 15 divided by 12 will get us how many ounces are in each one of those tubes. So 15 divided by 12 is literally 15 divided by 12, and dividing both top and bottom by 3, that's going to be 5 over 4. So we can say this is 1 1/4, or 1.25. So 1 1/4 ounces of red paint for each tube. Okay, so it's going to be 1.25 ounces would be our answer here. Okay, so if you happen to be working on some of these enrichment type problems, I hope that going over a few help you kind of understand what you're doing. I didn't go over obviously every single problem here, but I did go over a little bit of each type so that you had the right idea in case you wanted to check what you were doing. Okay, that wraps up this video on this answer key. So hopefully it made a lot of sense and it clarified any questions you might have had. But as always, feel free to come to office hours or shoot me a message and I'll be happy to work with you some more. All right, I'll talk to you guys in the next one. Bye.